Imagine a world where mice were like us, struggling with their weight and trying everything to shed off those extra pounds. The research team had been studying the impact of magnesium on metabolism, and through their experiments, they discovered something incredible. By deleting a specific gene that promoted magnesium transport into the mitochondria, they found that the mice became more efficient at burning sugar and fat in their energy centers. These little power plants were suddenly working overtime, and the mice started losing weight rapidly. They were no longer sluggish or tired, but instead, they were lively, energetic, and most importantly, healthy. Their researchers were ecstatic with the results and began exploring how they could replicate this effect in other mice and possibly even humans. After months of testing and experimentation, they finally developed a small molecule drug that accomplished the same effect in mice. They called it CAC, and it worked by restricting the amount of magnesium transfer into the power plants, forcing the body to use up its fat reserves to produce energy. It was like a miracle drug, and the mice who were once struggling to lose weight were now slim and healthy. The researchers were thrilled with their discovery, and they knew that it had significant implications for humans too. This drug could potentially reduce the risk of cardiometabolic diseases, such as heart attacks and strokes, and even lower the incidence of liver cancer, which is often linked to obesity and type 2 diabetes. It was a breakthrough that would change the lives of millions of people worldwide. As they continued their research, they imagined a world where people no longer had to struggle with their weight or worry about their health. It was a world where everyone could be healthy, energetic, and happy, and they knew that they were one step closer to making that a reality. As indicated by teacher Madesh Muniswamy, a medication master from the Wellbeing Science Focus Joe R. What's more, Teresa Lozano Long Institute of Medication, when mice are given a medication for a brief time frame, they shed pounds and become thin. This was found by Muniswamy, who is the senior creator, alongside teammates from the College of Pennsylvania and Cornell College. Their examination was distributed in the Cell Reports Diary on February 27. The examination group found a medication that influences digestion, which is the creation and utilization of energy in cells. They tracked down that magnesium, the fourth most plentiful component in the body after calcium, potassium, and sodium, assumes a key part in directing glucose and pulse, building bones, and dialing back energy creation in cells' power plants, called mitochondria. Erasing the quality that advances magnesium transport into the mitochondria brought about more productive digestion of sugar and fat, prompting thin and sound mice without greasy liver infection, a complexity connected with less than stellar eating routine, stoutness, and type 2 diabetes. The medication, called CAC, limits how much magnesium move into the power plants, which additionally brought about thin and sound mice. The scientists have documented a patent application on the medication. The mice were utilized as a model arrangement of long-haul dietary pressure brought about by a calorie-rich, sweet, and greasy Western eating regimen, which prompts corpulence, type 2 diabetes, and cardiovascular confusions. Bringing down the mitochondrial magnesium moderated the unfavorable impacts of drawn-out dietary pressure, said co-lead creator Manigandan Venkatasan, Ph.D., postdoctoral individual in the Muniswamy lab. Partners from the College of Pennsylvania and Cornell orchestrated the little atom drug, and the task was subsidized by the Public Organizations of Well-Being, the U.S. branch of GARD, and the San Antonio Association for Accuracy Therapeutics. This medication has critical ramifications in lessening the gamble of cardiometabolic sicknesses, for example, coronary episode and stroke, as well as decreasing the occurrence of liver malignant growth, which can follow greasy liver illness.